This is Algebra 2 at Trig 1A.2. We're going to solve absolute value equations. Something we're reflecting back on is how does this look like for an absolute value graph that's going to cross a linear horizontal graph. So a reminder that our h value is -1 and our k value is +5, and I notice our slope is -2. So I'm going to go 1 to the left and I'm going to go up 5. So that's my vertex of my absolute value. Then I'm going to do my slope of down 2 over 1 all the way down to the edge of the axes. Then we go down to backwards 1 with the opposite slope to show the absolute value v that we're expecting to graph. This is all a review, bless you. So we have our absolute value. We've graphed it. I would love if you could write out the equation with this also, especially if we're doing a system with two graphs on the same grid. Now we have our second equation we're doing. This is y equals 3. So I'm highlighting all the points where the y value is always 3. That's a horizontal line. When y equals 3, it's going to cross the y-axis. If the equation happened to be x equals 3, it would be crossing the x-axis. It's one way that I remember, is it supposed to be horizontal or not? All of these coordinates have a y value of 3. So that's why the line goes horizontal. So look what we have. We have a horizontal line crossing our absolute value at 2 spots. It's crossing twice. We can have 2 different answers. 2 different x's give us the same answer of 3. So what's the value of x that's going to give us an answer of 3? There's 2 possible answers that give us an answer of 3. When we come down here, we're going to try to do this algebraically. It's the same equation. We're trying to figure out where this absolute value is going to equal 3. Here are the notes. To solve an absolute value equation, we're going to take our absolute value function and we're going to isolate the absolute value. You're going to get the absolute value all by itself. That means we're going to bring the 5 across, we're going to divide out the 2, and we're going to get the absolute value bars on one side of the equal sign. Then we're going to rewrite it as 2 non-absolute value equations, and we're going to solve. Let's talk about that. So we're going to minus 5. That's just our algebra. So that gives us -2. So far we're okay. We're going to divide by -2. That crosses those off. This becomes a value of 1. So we have the absolute value of x plus 1 equals 1. So our absolute value equals 1. First of all, absolute value always has to equal a positive number. So if you have a situation where the absolute value equals a negative number, you know there's something wrong. There's no way that that can happen. No real solution. So we're looking at trying to determine what does the inside number, what would the inside number possibly be that you're taking absolute value of to make it equal the number 1. It's almost a trick question. What do you take the absolute value of to get 1? 1. So if the inside equals 1, that is one way that this could work out. What if the inside of the absolute value was something different than 1? What would taking the absolute value do and still make it the value of positive 1? What could the absolute value, inside the absolute value, be? You haven't even taken the absolute value yet. What's the inside? What could that number be total to make this pop out as a positive 1? It could be 1 and it could be negative 1. Think about what that means. Inside the absolute values could be a positive 1. Inside the absolute values might be a negative 1. When you do your calculation of the absolute value, that's going to turn it into a positive. Okay, long story short. You just take your absolute value and you write it here without the bars. Simple enough. And you take what you're equal to and you change the sign to plus and minus. That's all you got to do. But for you to understand why you're doing that, what are you actually performing? Why does that work? You're looking at what the inside is going to be. It might be the positive version of that, and it might be the negative version of that. Because the absolute value forces it to be positive. So now we can solve. Minus 1, minus 1. So when x is 0, we should get an answer. Minus 1, minus 1. And when x is negative 2, we should get an answer. Remember, when we graphed the same equation up here, we got an x value of 0. 0, comma 3 was one solution. And negative 2, comma 3 was the other solution. So here we got 0 and negative 2. Okay, so we got two answers. So let's come on over here. We have negative 3, or we have 3, right? So we're going to subtract that 3 to the other side. That gives us 2x minus 9. This is in absolute values. This equals 15. So what we need to think, inside the absolute value bars, if that was the number 15, take the absolute value of 15, we're going to get 15. So what we need to know is, when does this become 15? 2x minus 9 equals 15. When's that going to happen? What's the other situation? When the inside is negative 15. So that's 2x minus 9 equals negative 15. Those are the two situations we're looking for. Just take the absolute value, what's inside of it, and write it twice. And take what it equals and write it exactly the way it is and change the sign. That's how you do them. Just plus or minus that value. Then you do the math. Just regular algebra now. 2x equals 24, divide by 2, and we get 12. Plus 9. We get negative 6, divide by 2. We got negative 3. If you want to come in here and plug in a 12, 12 times 2 is 24, minus 9 is 15. Absolute value of 15 is 15. plus 3 more is 18. It worked. Then we can take our negative 3, plug that in. 2 times negative 3 is negative 6. Take away 9 more is negative 15. Absolute value is positive 15. Plus 3 is 18. It worked. I checked my answers. You should always check your answers. What we want to show you is that you can also use a calculator to come up with these answers. So let's discuss that real quick. So when we use a calculator, we're going to check our answer here. Okay? We'll check this one. What I've always suggested to you when you turn your calculator on is to hit second plus. I hit the plus sign down here. That gives me this menu. I want to go to 7, then 1, then 2. What that does is it cleans your calculator. It takes all the equations out. It puts your Windows values back to the beginning. Okay? Takes away all the errors that could possibly be happening. So we go to y equals. We type in our equation. We've done this in the past. So we hit math. Hit the math button. We go over to number. And there's ABS. That's absolute value. So we're going to hit enter to display absolute value. We're going to type in 2x minus 9. 2, the x value is right next to alpha. And we say minus 9. I need to use my arrow button to move out of the absolute value so I can write in plus 3. So then we hit enter. That's my first equation. This is my second equation. Simply an 18. So I've written that in here now. And I hit graph. So I have my absolute value, but I have my extra line way up here somewhere being 18. I can't see that on my window that only goes up to 10. I'm up here at 18. So I need to change my window. Right here is window. Which value in this list do I need to change so I can see farther up? The Y maximum. So we come down here, we need a number bigger than 18. Okay, 25 is great, 24, 23, 22, any of those numbers would be good. There's my absolute value, and there's my 18. Okay? Now, notice that my 18 line is not touching my absolute value on this side. What do I need to change so I can see where it touches? I need to change the X max in window. Now, before we just go guessing what number, I don't know if it's 20 or 30 or 40 or 50, is there a way that we could know better? Well, there is. Thanks for asking. We're going to go to second graph or second table. This is the table of those two equations. When x is 0, the one equation's at 12, the other one's at 18. When you start to scroll down, get larger x's, your absolute value is coming down. Your other equation is still 18. And if you go far enough, the absolute value starts to climb again. The other's always 18. Eventually, both equations are the same. That happens at 12. So I need a number bigger than 12. 15, that's nice. So Windows, X max is 15. There it is. Got it to fit. Putting in 100 would not be a good approximation. So now let's talk about where they're crossing. Using your cursor to go get it is not a good method. It's not going to be very accurate. You'll never land right on the spot. That's not right on the spot. That's not the exact answer. Okay? Hitting trace is not a good option. You will never use trace. That's not the exact answer. So that's not good enough. What we are going to do is hit second trace. Then we can go down to intersect because we want to know where the two graphs intersect. It's going to ask us two questions. Actually, three questions. It says first curve. Is this equation your first curve? For many of you, I bet the cursor is down here somewhere. Okay? Is this your first curve? And the answer is yes. You typed it in. It's not trying to be tricky. You typed it in. It's giving you the option to have like 3, 4, 5 different equations typed into your calculator. But you have 2 equations in your calculator. So it's always enter. Yes, that's it. Is this your second curve? I don't like the word curve. I wish they'd say equation. Second equation. Say, yes, this is my second equation. Y equals 18 is my second equation. Hit enter. Of course it is. Now it uses the word guess. Sometimes guess is not overly important. If you have 2 linear lines that only cross once, it's not important where you're guessing. You're close to the answer. Even if you're not close, there's only one answer, so you're kind of close to it. But here, there are 2 answers. So you need to get your cursor closer to the answer that you want. So let's say we want this answer. So I have to move my cursor to get closer to that answer. So I'm closer to this one than I am to that one. Closer to it. I'm close enough. Get closer if you want. Doesn't matter. Hit enter. And it gave me that answer. Gave me the intersection. When x is 12, I got 18. Do it again. Second trace, number 5, first curve, second curve, guess. Well, I got to get closer to that side this time. So I come over here, get as close as you want, and that's my answer. When x is -3, I get 18. There, we've done it. We're going to do this in every unit, or in many of our units. This is not going to go away. You do need to know the process. But there's our 2 answers, 12 and -3. We knew that those are accurate answers. We solved it algebraically, and now we solved it using our calculator. On your test, you'll have a portion of your test that you must show algebra. And you might have a test where you're allowed to use your calculator. All right. So we verified our answer using our calculator. So here's an equation. Notice how there's an M on both sides. That's a big hint that there could be a concern about that. This can make extraneous solutions. Okay, having M's on both sides. An extraneous solution occurs when solving some equations. A solution that is not valid when testing back into the original equation is considered an extraneous solution. Your math is perfect. You plug it back in, it doesn't work. That answer is not considered wrong. It's considered an extraneous solution. So let's go ahead and try it. My absolute value is already isolated. So I'm going to take 15 plus m and equal this to exactly what I see. Negative 2m plus 3. That's exactly the way it's written. And then we're also going to plug it in. 15 plus m equals the opposite of negative 2m plus 3. Because this is a binomial, I need to put my negative sign with parentheses, just so we do the opposite correctly. You don't want to make a mistake and only do the opposite of negative 2m. You need to do the opposite of both terms. So we just do the math now. My plus 2m plus 2m. That gives us 3m. I like my m to be positive. So I wanted to move my 2m to the left. Your choice. Minus 15 minus 15. I can't help this, but it's negative 12. This is divide by 3, divide by 3. I get m equals negative 4. Now we have to determine, is negative 4 accurate? Or did something weird happen in here where that's not the real answer? In the future, you're going to find out that the negative answers are often the one that is extraneous. It happens a lot. But that's not the rule. It only happens a lot. It's not the rule. It doesn't have to be. It depends how the equation is written. So we're going to test it by plugging it back into the original equation. Absolute value of 15 plus the negative 4 equals negative 2 times negative 4 plus 3. Does this actually work? So we get 15 minus 4, that's in absolute values. Negative 2 and negative 4 is 8 plus 3. This becomes the absolute value of 11 equals 8 plus 3, which is 11. And hey, that works. Absolute value of 11 is 11. So check. That worked out perfect. So this is actually a solution. We can circle it. You checked it. You verified that it worked. How do you know when you need to check it? It will usually give you a hint. Watch out for extraneous solutions. But definitely, if you have m's on both, if you have the variables on both sides of the equal sign, that's your common need to watch out for extraneous solutions. Let's see how this one works. You're going to distribute your negative in. So this is 15 plus m equals positive 2m minus 3. Now we've done the opposite of that side. Just algebra. So we subtract the m. We get 15 equals m minus 3. We add 3. We get the answer of 18. Is 18 a real answer? It might be. You might have two answers that work in this case. You might. So we're going to plug that in. Absolute value of 15 plus 18 equals negative 2 times 18 plus 3. So this comes out to be 33, the absolute value of 33. This comes out to be negative 36 plus 3. And when you take the absolute value of a positive 33, you get a positive 33. So, of course, 33 does not equal negative 33. That did not work. So, extraneous solution. And we make a light X over your answer. Don't erase it. Don't ignore it. That's your extraneous solution. So you put a light X through it. And then we write the word extraneous, just the way it sounds. Solution. So we have one real answer. We just have negative 4 as our answer. We could try it in our calculator. And I'll do this one even faster this time. I have stuff in my calculator already, so instead of changing windows and changing my y equals and trying to clean my calculator, second plus 712 clears it for me. And my windows right back to negative 10s and 10s. My y's are all empty. All takes care of itself. Just a good idea, not a requirement, except when it comes time for the test. So we're going to do the absolute value of 15 plus m. I have to use x for any input variable. And my second equation is negative 2 m plus 3. When I graph this, I notice that the graphs are not lining up together. It looks like I need to go a little bit higher to see that cross. How high up do I need to go? I'm not sure. It doesn't look to be too much more than 10. I could take a look. If you go to table, second graph, to go to table, when x is getting bigger, notice my absolute value function is getting bigger. All right, that was way too big. Let me take another look. Oh, those are negative x's, right? Let's go to negative x's. Second table, negative x's. Hey, there's where they line up. They're lining up at 11, and it happens at x is negative 4. So I know I need to look above 11. So in in Windows, what am I going to change? The y maximum. What number should I change it to? Something bigger than 11. Okay, 15, 16, 17. There it is. I found it. But Mr. Weber, I thought we had an absolute value function here somewhere. Okay, if you look back at table and you make your x's go even smaller, look, this is going down, 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 down. And then it starts to go back up. Okay? So if you get out here at about 20 or 24 or something like that, you can really see the absolute value bar. Notice that the absolute value and our other line don't have the same slope. This one is closer to vertical. This one is slanted more. They have different slopes. They're not going to cross. So this one's not going to hit it over here eventually. If it was like this, it would. But they're never going to intersect. That's why it only crosses one time. Second plus, number 5, or second trace. Number 5, first curve, second curve, guess. And it gave us our answer at negative 411. Okay, so we practice it again. So we just did it with our calculator and got negative 4/11. Sometimes it's good to draw a little sketch of your grid. And right here would have been negative 4/11. That's what we just had. Now you can go ahead and try this one. I'll put my pencil down, you pause the video, and then start it back up, and I'll walk you through how to do this question number 4. But you go ahead and try it on your own. All right, let's see how you did. So, because the absolute value is isolated, we don't have to add or subtract or divide anything. We're going to take our 4x plus 10 and equal it to 6x. And we're also going to take our 4x plus 10 and equal it to negative 6x. So now we're going to check our work. 10 equals 2x. We're showing our work. We get 5. When I plug 5 in here, I get 4 times 5 plus 10 equals 6 times 5. That's absolute value of 30 equals 30, and of course it does. That equals each other. So check. That's a real answer. Now I can come over here and plus 6x plus 6x, because I don't like to have my leading coefficient be negative, so I'm going to move my 10 to this side. And when I divide, I get the answer of negative 1. When I plug negative 1 in here, 4 times negative 1 plus 10 equals 6 times negative 1. Negative 4 and 10 is 6. This is negative 6. Absolute value is 6 does not equal negative 6. This didn't work. That's extraneous. So I only have one real solution. And you can try representing that in your calculator. You'll see that it touches once. This one's very interesting. All right. It'll be more fun to show it to you in a calculator first. Second plus 712. So I don't have to clean the calculator myself. My y equals was 5 plus 2 times the absolute value of x minus 4 and 1. Notice where the 5's at. Isn't that a funny place for the 5? That's going to happen more and more in some maths. And many of you are going to get all confused on what that 5's are. That's your k value. That really belongs on the right-hand side, plus 5. This is not 7. You can never call that 7. All right? But either way you want to write it. So when you graph this, notice what happens. Do the graphs cross at all? No. This absolute value has a vertex. It's like 4 to the right and 5 up. And they want to know, when is it going to be equal to 1? It's never going to be equal to 1. So there are no real solutions. If you were to use algebra for this, minus 5 minus 5, 2 times the absolute value of x minus 4 equals negative 4. Divide by 2, divide by 2. Absolute value of x minus 4 equals negative 2. Can an absolute value equal a negative number? That's impossible. Right? Doesn't the absolute value always have to equal a positive? So I know right now, no real solutions. Because absolute value can never equal a negative. Don't get that confused with needing to do more work, right? If you had to add 5 over, maybe you turn it into a positive. But this actually turned it into a negative. Good job, everybody.